Determine whether the events are mutually exclusive or inclusive. When we say the word inclusive, we know that it's actually the same thing as overlapping. Go ahead and write that in now. Overlapping. That's what we learned about last class. It says then find each probability. That's exactly what we're going to do. We're going to find it as a percent. Okay? We're going to determine if it's mutually exclusive or overlapping. Then we're going to find the probability as percent. Finally, we're going to add one more thing to our directions. That is to draw out the sample space. Draw out the sample space. Okay? And there's just a list of all the possible outcomes. Okay, all possible outcomes. So looking at number 1, there are three literature books, 4 math books, 2 science books on a shelf. If a book is randomly selected off the shelf, what is the probability of selecting a literature book or a math book? So let's first determine, are they mutually exclusive or overlapping events? The things we have to ask ourselves, is it possible for one book to be multiple categories at once? And the answer is no. So therefore, it's not overlapping. These are mutually exclusive events. Mutually exclusive events. Great. In order to find the probability, the easiest way to do that is actually to draw out that sample space. So we have 3 literature books. 1, 2, 3 literature books. We have 4 math books. And we have 2 science books. All right, what we have to find out are what are all the favorable outcomes. Literature and math books are our favorable outcomes. I'm going to draw a blue box around our favorable outcomes here. Great. And so from here we can tell that there are 7 favorable outcomes over a total of 9 possible outcomes. All right. So we found the probability. I said I wanted to find that probability as a percent. Let's talk about how we actually find percents. The way we find a percent is in a calculator. We're going to do numerator divided by denominator times 100. Okay. Numerator divided by denominator times 100. So in this case, we'd have 7 as our numerator divided by 9 as our denominator times 100. And we'll get 77.7 repeating percent. And let's go ahead and just round this to the nearest tenth. This is 77.8%. Okay, 77.8%. So we drew our sample space. We figured out if they're mutually exclusive or overlapping. We found our probability as a percent. That's all we need to do. So that's number 1. Those are mutually exclusive events. Number 2, a single die is rolled. What is the probability of rolling a 5 or a number greater than 3? Again, we need to ask ourselves, mutually exclusive or overlapping? So in this situation, is there a number that fits both categories? The answer is yes. 5 fits both categories, so this would be considered overlapping events. Okay, overlapping events. Okay, let's draw out the sample space. We have 1, 2, 3, 4, 5, and 6. So a number that is a 5 or greater than 3. All right, so we have 5. That's an option. Or a number greater than 3. That's 4, 5, and 6. All right. Remember, we can't count a number more than once. So we can't count that 5 twice, even though it's circled twice, and that's okay. We see that there are 3 favorable outcomes over 6 possible outcomes. That reduces down to 1/2, which we also know is 50%. 50%, okay? So far, so good. Now, this last one, number 3, is going to be the trickiest one of the 3 we do together. It's going to be one of the trickier ones on this whole homework sheet. Let's take a look at number 3. On the debate team, 7 of the 20 females are seniors. 4 of the 14 males are seniors. What is the probability of randomly selecting a female or a senior to represent the debate team at a statewide competition? All right, let's first determine, are these mutually exclusive or overlapping events. Okay, we have to consider, is there a scenario where a student could be both female and a senior? And the answer is yes. So the fact that one person could represent both categories tells us these are overlapping events. Now, here's what we're going to do. We're going to draw a sample space. There are 20 females. So let's draw 20 Fs. Just the initial is fine, okay? F, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 females there, okay? And the problem tells us that 7 of those 20 females are seniors. And that's important. I'm going to highlight, you can underline these, but we're going to highlight 7 of these Fs to indicate that of these 20 females, 7 of them are seniors. I'll do a smaller. There we go. So we have 7 females of those 20 are seniors. Okay, let's do the same thing with the males. We can see that there are 14 males, 4 of them are seniors. Okay, let's drop 14 Ms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, great. So we have 14 males, and we know that 4 of them are seniors. Okay, so just like we did with the females, we're going to highlight the ones that are seniors here. Okay. So the question asks us to find what's the probability of selecting a female or a senior. Okay, well, I know that all of the females count. All of the females count. Okay, I also know that the seniors count. So whether they're male or female, the seniors count. So I'll draw a big blue box around everyone who counts for the situation, okay? What we find is that there are 24 favorable selections, 24 students who are either a female or a senior, so they fit the category, okay? Female or senior, and there are a total of 34 students. Total of 34 students, okay? 24 of these students are a senior or female out of 34 total students. This, of course, reduces down to 12 over 17, and then that as a percent is 12 divided by 17 times 100. This is 70.6%, okay? So go ahead and work on the remaining 9 problems. Make sure we hit everything we need to, find the probability, determine if they're overlapping or mutually exclusive, draw out the sample space, then write your answer as a percent. Okay? All right.